In this video, we are going to study the last chapter of grade 10, that is Natural Language Processing or NLP. This is the theoretical part of the chapter. After this, we are going to have a practical explanation for this chapter too. This is the explanation video. We'll also have a question answer video for this, where you will get all sorts of question, application based, long questions, short questions, MCQ based, true, false, and all sorts of questions. Okay, please watch this video till the very end, because every point I'm going to tell is important. Okay, the bag of words, all the different algorithms that you use for NLP, those are very important. So make sure you do not miss anything. Okay. As this chapter is about natural language processing, it's very important we know that is what is natural language. Natural language means the language in which we humans communicate with each other. Okay, like Chinese, Japanese, English, Korean, Bengali, Mandarin, all of this. Okay, humans are using it. It's very colloquial. It's very like there are a lot of slang terms and colloquialism that is going on. So these languages evolve over time. In Shakespeare time, they used to call thou art is great. Now we call it your art is great. So languages evolve over time. And now for this natural language, we have certain rules to govern this natural language. What are those rules? First is syntax. Syntax means the set of grammar rules that first we use the subject, then the verb, then the object. Like, so if I say she is eating food, that is syntactically correct. But if I say eating food she is, so that is not syntactically correct, right? Because it is not adhering with the grammar rules. So the first rule is syntax. Then we have lexicon. Lexicon means basically it is the vocabulary of the language or the dictionary of the language. Like English has its own lexicon. Okay, English has its own lexicon. Mandarin, Bengali, all of them have their own lexicon. Okay, like English has words like beautiful, walk, idea, dress, mic, microphone, hair, all of this. Okay, so this is the English lexicon. Then, so the third one is semantics. Semantics means it deals with the meanings of words, phrases, or sentences, and the way we use it, it affects the meaning. Okay, so if I tell I played with the bat, so here the word bat, it obviously doesn't mean that flying mammal, right? That is not the bat I'm talking about. The bat I'm talking about this bat, the cricket bat. So this is how semantics is important. In what context are we using a sentence, a phrase, or a word? It catches the meaning. Natural languages have some features. That is, first is they are governed by a set of rules that we already talked about: syntax, lexicon, and semantics. Next is all natural languages are redundant. That is, information can be conveyed in multiple ways. So I have an idea that I'm going to school. This idea can be expressed in many other forms, like I'm heading towards school, I will go to school. The natural languages can be redundant. We can convey our information in multiple ways. Okay. And third is natural languages change over time. As I told you in the beginning, then new words got added like selfie, vlog, emoji, you're very cool. So it doesn't mean that you're cold, but you're very cool. We say all of these things, the Gen Z terms, right? The language has evolved over time. Now, let us understand the difference between human languages and computer languages. So, human languages, the sole purpose is to communicate with people, right? But in computer language, the sole purpose is to give instructions to the computer. Right? In human language, you have examples like Mandarin, Chinese. Obviously, it is used to communicate with people. And in computer language, like we have Java, we have Python, we have C, we have C hash, C++, all of that. So they are used to give instructions to the computer so that the computer can perform a particular task, right? And human languages, they evolve naturally, just like I said before. And computer language, they don't evolve because they are designed by humans. They are artificially created. They have a set rules for semantics and syntax, right? In human language, we have certain rules, right? But who follows those rules? When we are talking, we talk very freely. We don't care about grammar and all. Human languages are flexible. You can bend and break it. But computer language is not at all flexible. You create one, you miss one semicolon in Java and it gives you syntax error, right? So computer language is very strict about it. Now there is a domain in artificial intelligence, that is natural language processing. We have three domains, right? Statistics, computer vision, and your NLP. Now NLP, or natural language processing, it is that domain in artificial intelligence that totally deals with understanding, interpreting, comprehending, and generating human language. Okay, so it helps in the tasks like speech recognition, translation, or summarizing text, sentiment analysis, all of that, where interaction with human language is needed. So now we are going to study about the stages in natural language processing. Here we are giving a text as input to the system, and that will be processed in 5 steps. Okay, that 5 steps you are going to see. So for example, for the whole explanation, I am going to take one sentence, which is book the flight to Delhi for tomorrow. Okay, this is the input text that we are giving to the system, to the AI model or the system. Okay, now what are the steps that the NLP would undergo? First is lexical analysis. Lexical analysis, the input text, it is broken down into words or tokens. Okay, these are also called tokens, and it will check if every word is a valid word or not. So the sentence book the flight to Delhi for tomorrow, it is separated, or it is broken down into words. Now it will check if the spelling is correct, then it will classify it into the parts of speech, noun, verb, adjective. It will classify each word into these noun, adjective, all of this. Okay, it takes help of the lexicon. Because it is lexical analysis, it takes help of the lexicon, which we already studied. It's a vocabulary of words. Okay, if the text is in English, it will take help of the English lexicon to find out which word is a noun, verb, or adjective. Okay, in the next step, which is syntactic analysis, it checks the syntax of the words, that it checks the syntax of the tokens, or this is also called grammar check. Okay, so it will check if the sentence is grammatically correct or not. Okay, book the flight to Delhi for tomorrow is syntactically correct. But if we have a sentence like flight the book to Delhi for tomorrow, does it sound syntactically correct? Obviously no. So this will be not approved by the syntactical analysis step, and an error will be given. Now if any other module is there, other NLP module is there, it will correct this statement. Okay, but in syntactical analysis, in this step, nothing will be corrected. Okay, there will be another module which will correct this statement. Okay, or this sentence. Now the third step is semantic analysis. Semantics means deals with the meaning of the sentence. So here, book the flight to Delhi for tomorrow, it understands the meaning. Okay, it understands the meaning that the sentence is trying to convey. Okay, it studies the words, the individual words, and then it finds the meaning of the sentence. Like here we have book the flight to Delhi for tomorrow, so it understands that book is not the book that we read here. Book means to reserve a flight. Okay, flight to Delhi means it is an airplane trip to Delhi. Okay, tomorrow means a time. Okay, so it understands this in semantical analysis. And next we have discourse integration. Discourse integration in this step, suppose we have two sentences, book the flight to Delhi for tomorrow, and sentence 2 is make it early morning. So in sentence 2, make it early morning, so what does it refer to here? You get this type of RTC questions in literature, I guess. So it refers to the flight to Delhi in sentence 1. So here we can see that a relationship that is established here, that it means the flight. So a relationship is established here, right? And discourse integration means when there are multiple sentences, it tries to establish a meaning or a relationship between the sentences. Okay, so if there are pronouns like it, she, he, they, this, that, so all of this in discourse integration, these pronouns, it tries to connect with the correct nouns of the previous sentences. Okay, so if I have a sentence like Rahul is a very good boy, he comes first in the class, so he, this pronoun, it tries to find what will be the correct noun for this pronoun that I can establish a relationship for. So he is Rahul. That I'm trying to say. In discourse integration, this happens. Okay. Last step is pragmatic analysis. In pragmatic analysis, we actually focus on what the speaker is actually trying to say in a real world situation, what it is trying to say. So it understands the context of the sentence, the tone, the mood, the common sense of the user. Okay. So we have the sentence, book the flight to Delhi for tomorrow. So here it is a request or an order, right? That book the flight or please book the flight. So it's an order or a request. So pragmatic analysis understands this, that in a real world situation, maybe the speaker or the user is trying to tell the travel agent to reserve a flight ticket to Delhi for him. So he is going for a vacation in Delhi. So it tries to establish all these real world relationships. Okay. So if we have another sentence like teacher says it is very noisy here. So the literal meaning or the semantic meaning, that will be the noise level is very high. But in pragmatic analysis, it understands that the teacher is probably or indirectly telling the students to be quiet. Okay. So let us put it all together. So in lexical analysis, sentence is broken down into tokens. In syntactic analysis, the grammar is checked. In semantic analysis, the meanings of the words is checked, and so we get the total meaning of the sentence. Then in discourse integration, if we have multiple sentences, the relationship between the sentences or the pronouns of the sentences or the nouns of the sentences, that is established. Then we have pragmatic analysis, and here we understand the user's intention or the user's context, the tone, the mood of the user, and we try to find real world relationships with the sentence. Okay. Now let us understand the difference between a corpus and a document. So a corpus means a large collection of text, okay, of articles, of rhymes, of email, and a document means it is a single piece of text within the corpus. So if we imagine, if we give a paragraph to the AI model, okay, if we type a paragraph, then that paragraph is the corpus, and the sentences in the paragraph, they are the document. Okay, so the paragraph or the corpus is a bigger unit, and the document is a smaller unit within the corpus. Got it? So when we are giving a paragraph to the system, okay, or to the AI model, do we always write correctly? Suppose I'm typing very fast, I'm writing total nonsense, I'm giving total nonsense to the AI model. So first what it needs to do, it needs to understand my total nonsense, right? So we need to do text normalization here. What does that mean? It needs to convert my total nonsense into a standard readable form so that the computer can further process it, right? So text normalization is very important, because if I'm writing total nonsense, that needs to be converted into a standard form, right? So if I'm writing BTW, it needs to convert it into by the way. If I'm writing GRT, then it GR8 or GRT, it needs to be converted into great. If I'm writing GM, it needs to be converted into good morning. I'm saying great morning. We need to normalize the text. Okay. So there are certain steps for text normalization that we are going to study now. So if I give a paragraph, then first step will be sentence segmentation. Here the paragraph is broken down into individual sentences. Okay. If I give it something like this, I love traveling, I will book a flight to Delhi for tomorrow. Okay. So in sentence segmentation, this will be broken down into two sentences. I love traveling, I will book a flight to Delhi for tomorrow. Okay. So here sentence segmentation happens, it breaks the paragraph into two sentences. Okay. Now tokenization will happen. We already talked about this. Token means a word. So the sentences will be converted into tokens. It will be broken down into words. Okay. So if I each sentence will be having its own tokenization. If I take only one sentence here, book the flight to Delhi for tomorrow. So book the flight to Delhi for tomorrow. Now the third step is removing stop words. Stop words means the common words that do not add a major meaning to the sentences, okay, and if we keep them, it's a burden to handle those many words. Like stop words are the, a, an, is, to, for. Here we have the sentence, book the flight to Delhi for tomorrow. So here we have to remove the stop words, right? So we remove the, we remove to, we remove for. So now the sentence becomes book flight Delhi tomorrow. Okay, we have removed all the stop words, and this will help us to efficiently continue the other steps. Okay, next step is lowercasing. We have to convert all the text to lowercase so that they are in a standard equal form. So fifth step is stemming. We reduce the words that we have, we reduce it by cutting their prefixes or suffixes without caring about grammar, so that we can get the root form of the words. Okay, so if I have a word jumped, so it will remove the ed, okay, and it will convert it into jump. And this jump that we are getting, like after reducing the word by stemming, the thing or the word that we are getting, that is called stem. Okay, so if you have jumping, it will remove the ing, and the stem that we'll get is again jump. But if we have flies, F-L-I-E-S, flies, so it will remove the es, because it will only remove the prefix and suffix from a word. So it is removing the suffix es. Now what we are getting? FLI, fly. What is that? So the stem we are getting is FLI, fly. So this does not make sense. It is not grammatically correct or syntactically correct, or the spelling is correct, right? So in stemming, as I told, it cuts off the prefixes and suffixes so that we get the root word, but it does not make sense because it is done without caring about grammar. So the stem that we are getting, it is not always correct, because stemming is a very fast process. Okay, so it does not always give us the correct results, right? Now we have the sixth step, that is lemmatization, and here also we reduce the words to its base form, that is called lemma, and this is done using grammar and dictionary. Okay, it is not like stemming that we are doing it, we are just removing the prefix and suffix and the stem word, it does not make any sense. But here the lemma that we are getting, that makes sense, okay, because it is done using grammar and by seeing the dictionary. So here if I have jumped, it will remove the ed, and the lemma that we are going to get is jump. If we have flying, it will remove the ing and we will get the lemma fly. If we have flies, it will remove the es, but the lemma will not be FLI, fly, it will be FLY, fly. Okay, got it? So we can say that lemmatization is more effective than stemming. We get more accurate results in lemmatization, and obviously it takes more time than stemming. Now let us learn about chatbots. So chatbot is a program that communicates with the user in natural language or text or voice. Okay, now not all chatbots are programmed by AI. Okay, there are two types of chatbots. One is a script bot and the second one is a smart bot. Script bots, they follow a they are a chatbot which follow predefined rules. Okay, they don't need that much of programming. They are not programmed by AI, of course, and they can do only simple tasks. They have no intelligence of their own. They are programmed in that way. They are rule based. Okay, for example, I'm the user, I say hi. The bot says, hello, what would you like to order today? Option 1 pizza, option 2 burger, option 3 sandwich. So you reply with a number. I reply 1. So the bot says you selected pizza, choose size, A small, B medium, C large. So I say C. So bot says large pizza selected. Would you like extra cheese? Yes or no? So I say yes. So the bot says, okay, I've taken your order. So you want a large pizza with extra cheese. Do you want to confirm? So you get buttons confirm, cancel. So I say confirm. So the bot says your order placed, it will be here in 20 minutes. So this is how the script bot is. It is very programmed, okay? It will not let you type anything else. And if you type anything else, there will be generally there are options, okay? There are buttons and options and you select those. and it doesn't let you write generally, these type of chatbots, okay? And because they have no intelligence, if you write, what will they reply? Now smart bots are type of chatbots which use machine learning and they use NLP, and they understand the natural language and context. They learn from the past interactions with the user, that the user likes this, he likes this, he likes this, so I'm going to do something like this, okay? So for example, so I'm the user, I say, hey, I want to order something to eat. Smartbot says, sure, what would you like to have? Pizza, burger, pasta, or something else? So I say, usually I'm craving something cheesy, maybe an Italian dish. So the smartbot says, sounds good, how about cheese-filled Alfredo pasta or margherita pizza? So I say, give me pasta, make it spicy. The bot says, okay, got it. Order is spicy Alfredo pasta. Do you want extra cheese? So I say, obviously. So I don't say yes or no. I say obviously, just as I want to. A normal conversation. So here the chatbot uses NLP to understand what we are telling it. Got it? And lastly, we have applications of natural language processing. First, we have automatic text summarization. So we have very long documents. Now, so using abstractive summarization, what is happening is, we have long documents. Now using NLP, it rewrites those documents in its own language using a different vocabulary, and it produces short summaries of those long documents, okay? Next is auto-generated captions. So there are models which convert speech to text or image to text. So those kind of models are used along with NLP to create auto-generated captions, okay? Like in YouTube, we have auto-generated captions. And then we have machine translation. In Google, if you see, we have Google Translate. So it helps you translate from one language to the another, okay? And this involves the correct syntax for the language and also semantics, so that we can understand the meaning of the language, and accordingly we have to translate it to another language, okay? Then we have sentiment and emotion analysis. Sentiment analysis, that we call it generally. So it is used in product reviews. If you see, this product is very good, so that is a positive response, and the product is okay, so this is a neutral response. The product is horrible, this made my skin so bad, so that is kind of bad response, right? So using NLP, it understands the tones. Then NLP is also used in voice assistants like Google Assistant and Siri. So it understands your human language, and it also generates another human-like reply that it gives to you, right? That is also done using NLP. Okay. So now we are going to learn about the NLP algorithms, and I'm making this video here in the board because it will be easier to understand the algorithms here. Now the question is, why do we need an NLP algorithm? What is the need? Like here I have a corpus in which I have basically two documents, D1, D2. Document 1 is I love ice cream very much. Document 2 is I love mango ice cream. Okay, when I give this corpus to the machine learning model where NLP will be also used, so machine learning tells that I cannot understand this text, because obviously it's a machine learning model. How will it understand this text? It's not possible. It's a computer, not a human. Even when someone tells us something, our brain first processes it, right, in the form of neurons and everything. So machine learning model also tells that I also want this information in the form of numbers and not text. So basically you have to give the corpus or the documents, this text you have to give in the form of numbers. Now what numbers can we give? What are we going to give? So the numbers that we are going to give is called vectored or vectors. Okay, so we are going to present this information in the form of vectors. Now what is a vector? Suppose here we have a word. Here we have a word in this document 1, right? So this word I, the frequency of I, okay, the frequency of I, that will be the vector. So we will generate the vectors with our NLP algorithms. First, that is bag of words. This is the first algorithm that we are going to learn. Okay, so bag of words will return a vector value to you, and that you are going to feed it to your ML model so that it can give you output based on your text. Got it? Now, before doing any kind of process, first we have to normalize this text. Okay, that means first let us convert everything to lowercase. So this two i's I'll convert to lowercase, and anything else? No, we have to remove these punctuations, these full stops we have to remove, and others everything is okay. Yes, we have to do something that is called building vocabulary. Now, what is vocabulary? It means you have to find all the unique words from this corpus. All the unique words means there should not be any duplicates. Okay, there should not be any duplicate words. That is going to be our vocabulary. So I have listed my vocabulary in this table. That is, all the unique words are I. From both the documents I have taken one I. From both the documents I have taken one love. From both the documents I have taken one ice. From both the documents I have taken one cream, very, much, and mango. Okay, got it? So I have taken all the unique words. I have built my vocabulary. Now it's time to find the frequency of these words in both document 1 and in document 2. That means frequency means, I hope you all know, we have learnt it in mathematics when we were studying about graphs and all that. Frequency means the occurrence of the word. How many times does this word occur in document 1 and document 2? Okay, so if we talk about I, this word I occurs for one time in document 1, so the frequency will be 1. Love occurs one time in document 1. First we are going to focus on document 1. Okay, love occurs one time in document 1. Ice occurs one time in document 1. Cream also occurs one time in document 1. Very occurs one time in document 1. March also occurs one time. Mango, do you find mango in document 1? No, right? So mango has 0 frequency in document 1. Now we come to document 2. In document 2, I occurs one time, love occurs one time, ice occurs one time, cream occurs one time, very does not occur, much does not occur, but mango occurs. So mango also 1. So what is the vector that you have generated? So we can write vector generated, that we can write as, for document 1, we can write it as 1, 1, 1. There are 6 ones and 1, 0. So this is our vector for document 1, and for document 2, our vector is going to be 1, 2, 3, 4. 1, 2, 3, 4. Then 2 zeros, and then again 1. So this is going to be the vector that we have generated, right? And this is the vector that we have generated for document 1 and document 2, right? And this vector we are going to give to our machine learning models, and then the machine learning model can make predictions. Okay. Now there is one limitation of bag of words. This was the work of bag of words, which is very easy. Now there is one deficiency of bag of words, that is, if the document 1 was much longer, if the document 2 was much longer, the length of this table would have been much more, or the vector that we would have generated, that would be much more. So more the number of sentences, more will be the vector. All the less important words like love, I, these words are getting more weightage, right? These words are getting more weightage in bag of words. There is no distinctiveness that this word is more important or that word is more important in bag of words. That is one deficiency of bag of words. Like it cannot distinguish between
any words. It considers every word as equal, but every word is not equal. Some have very high weightage, some have really low weightage. So this is what deficiency of bag of words, and to cover up that deficiency we have something called TF-IDF. That is another NLP algorithm. Okay, now we are coming to the next NLP algorithm, that is TF-IDF. Now TF-IDF has certain terminologies. First that we are going to find out is TF, that is term frequency. Then we are going to find DF, that is document frequency. Then we are going to find IDF, which is inverse document frequency. And then lastly, finally, we are going to find out the TF-IDF. Now here we again have the same corpus, same documents as that of bag of words. First we have to find TF, as I told, which is term frequency. Now for TF, the formula is frequency of a term in a sentence by total number of terms in a sentence. So here if we start to calculate the term frequency of this particular corpus, and we'll calculate for each document. For each document we'll calculate the term frequency. Now first we have I. So frequency of term in a sentence. So here document 1. So in this particular sentence I occurs for 1 time. So frequency of I is 1 by total number of terms in a sentence. Total number of terms in document 1. 1, 2, 3, 4, 5, 6. So 1 by 6. Similarly for love, it occurs for 1 time. So frequency is 1 in document 1. Total number of terms is 6. 1 by 6. Ice also it will be 1 by 6. Cream also it occurs for 1 time, so 1 by 6. Very also it occurs for 1 time, so 1 by 6. Much also it occurs 1 time, 1 by 6. And mango it does not occur in document 1, so the frequency of the term will be 0. If we do 0 by 6, it will be 0, so let us just write 0. Now document 2, in document 2 I occurs for 1 time, so 1, frequency will be 1. Total number of terms in the sentence in document 2, 1, 2, 3, 4, 5. So in document 2 there are 5 words in total, so 1 by 5. Similarly love is occurring for 1 time, so that will be also 1 by 5. Ice also for 1 time, so 1 by 5. Cream 1 time, so 1 by 5. Very it does not occur, so 0 by 5, which will be 0. Much also it will be 0. Mango also, mango we have 1 time, so it will be 1 by 5. This is the term frequency of all the words in respective documents. Okay. Now we come to DF. DF means document frequency. Here it says DF equal to number of documents the term has occurred in. That means if we consider I, how many documents has it occurred in? It has occurred in both the documents, right? In document 1 also, document 2 also. So it has occurred in 2 documents. So the document frequency of I will be 2. For love, love also occurs in 2 documents. So the document frequency of love will be 2. For ice also occurs in both the documents. So the document frequency of ice will be 2. Cream also it will be 2. Very, it has occurred only in document 1, so 1. Much, it has occurred in document 1 only, so 1. Mango, it has occurred in document 2 only, so 1. So we have the document frequencies here. I hope you have understood. It is a number, okay? It is a whole number. Now we come to IDF, which is inverse document frequency, and the formula is total number of documents in the whole corpus by document frequency. If we see for I, total number of documents in the corpus, that will be constant for all the words. The numerator will be constant for all the words. So here are 2 documents in total. So 2 by document frequency of I is 2, right? So 2 by 2. 2 by 2 means we know it is 1. So we will just write 1. Then we have love. So this will be also 2 by document frequency of love 2. So this will be also 1. Then we have ice. Total number of documents 2 by document frequency of ice 2. So 2 by 2 we get 1. Then for cream also it will be 2 by 2. So 1. For very it will be 2 by document frequency of very 1. So 2 by 1. 2 by 1 we means it's 2. Then we have much. It will be 2 by 1 again. So it will be 2. And for mango, the IDF will be 2 by 1, which is again 2. So here we have got the IDF for all of our words. And lastly, we have TF-IDF. Okay. TF-IDF, it says that TF-IDF means TF into log of IDF. TF into log of IDF. For the word I, if we consider in document 1, here you can see document 1, if we consider for document 1, term frequency in document 1 for I is 1 by 6. So it will be 1 by 6 into log of IDF. So if you see I, it has, right, the IDF for I is 1. So log of 1. Now remember one thing, that log of 1 is 0. So if you calculate this, that is 1 by 6 into log 1. Log 1 means 0. So 1 by 6 into 0, it will be 0. For love it is again 1 by 6 into log 1, because IDF of love is 1, 0. For ice, it is 1 by 6 into log 1, which is again 0. For cream, it is again 1 by 6 into log 1, which is 0. Okay, now for very, the document frequency is 1 by 6. The term frequency is 1 by 6 and IDF is 2. So 1 by 6 into log 2. TF-IDF will be 1 by 6 into log 2. Okay, and then we have mango. For mango it is 0. So it will be 0 into log IDF. IDF of mango is 2. So log 2. 0 into log 2, anything into 0 is 0. So mango is 0. And then for document 2, term frequency of I is 1 by 5. So 1 by 5 into log 1, which is log 1 is 0. So it will be 0. Okay, then for love also 0. For ice also we will get 1 by 5 into log 1, which is 0. For cream also we will get 1 by 5 into log 1, which is 0. And then for very, 0 into log 2, which is 0. And then for much, we will have 0 into log 2, which is 0. And then for mango, we will have 1 by 5 into log 2. So this is what our TF-IDF looks like. Okay, hope you have got it. Now what can you infer from this TF-IDF table? For I, the IDF value is lower than the others. So it has got a low TF-IDF value as well. Okay, because in IDF you have document frequency. So the more you have document frequency, that means your word is occurring in more documents. So if a word is occurring in most of the documents in your corpus, then it is going to be it is a very common word, and the machine learning model should not pay much attention to that. If it is a common word, why will you pay more attention to that? If you have more document frequency, you have automatically less IDF, because this is in the denominator. Document frequency is in the denominator, so it will be inversely proportional. So if the document frequency increases, that means your word is more common, it is present in more documents, it is more common, then you have lower IDF value. If you have lower IDF value, then you can see, if you have lower IDF value, then you have lower TF-IDF value as well. And if you have lower TF-IDF value, that means your word, that particular word is not that important, and machine learning model should not pay much heed or much attention to that. Machine learning model should pay attention to only distinct words. The words that appear less in your sentences, they are giving more weightage. They are given more weightage. So this value 1 by 6 into log 2, if you multiply this in your calculator, you will get a 0.005, some value like that. Okay, so it is obviously greater than 0. That means if your TF-IDF value is higher, that means the word has more weightage. So you can see that I love ice cream and mango, they are having low weightage in document 1, but very and much, these two words are very distinct and they do not appear in document 2, so they are having more weightage. Okay, so ML algorithm or the ML models will pay more attention to that. In document 2, you can see I love ice cream very much. These are not having that high weightage. Okay, these are not having that high weightage, but mango is having a very high weightage because this is a distinct word. These words are repeated. This is just a very small corpus, and it is a small sentence. So this can TF-IDF can help accommodate a much bigger corpus. This is how TF-IDF is more beneficial than bag of words. So that was it for this video. I hope you understood NLP. If you have any more questions, you can leave them down below in the comments. Till then, keep learning, keep practicing, and keep exploring. Thank you and bye-bye.